Hello everyone. I Nilesh Kumar Sen, working as an assistant professor in ABES Engineering College, Ghaziabad. Our topic is virtual memory. So virtual memory is what the before learning about the virtual memory, one need to learn about primary memory or RAM. As we all know about that RAM is expensive and limited in the system. So the secondary memory is what the cheaper is and the larger one also. It can also be extended easily. But the virtual memory concept offers what the new or some unique solution for apparent primary memory expansion. In this, what we use secondary memory as an extension for the main memory. The secondary memory can also be accessed if it were the part of the main memory. There are some techniques to use or to extend RAM with the help of secondary storage temporarily. It is obvious that there are some hardware and some software supporting for the same, and the operating system is also there to make it possible to use secondary memory as the primary memory. So as you can see in the diagram that this is what our virtual memory. So our complete process is converted into the pages, and those pages are loaded into the main memory. If main memory is capable enough to store once in a whole, then that will be loaded into the main memory, and that memory will be accessed by the processor. What if the number of pages are larger than the actual capacity of the RAM? In that very case, we store those pages into the secondary memory, and those uh, and which is RAM is capable take up to that much pages will be kept inside the main memory, and remaining are stored into the secondary memory, and all those pages are referenced with some memory mapping, and we'll discuss later about the techniques. So those memory mapping will fetch accordingly and uh, uh, when and then required about those pages which are missing. So those are located where inside the physical memory. So the memory is stored in the form of, as we discussed, units. Those are called what the pages, and these atomic units where large programs can be stored. For a particular program, like suppose there's a large set of storage in physical addresses. All those all those are not required to be loaded as once, as certain programs are already used, like as operating system is already filled inside the RAM. So this is what remaining portion is left with. So most of the time it is not possible to accommodate all the pages. So um, as like a game, FIFA on our desktop, it is having what a large number of pages. Game itself stored in the hard disk, but while playing particular, a sample space or a particular required space will be loaded into the RAM. But the whole game is not capable or not be able to be stored inside the RAM. Addressing a scheme that is provided by the system and the total available space in secondary storage device is what the limits and the size of the virtual storage, not the size of the primary storage or the RAM. Let's suppose if the storage is unlimited, as in the case of cloud systems, and some applications can behave as if they have unlimited primary memory available to them. So, in this very concept, what we use is the hardware and the software one. Both work together to map virtual addresses, which is generated by the CPU, and with the physical addresses at which the remaining portion of the pages or a particular process are stored inside the secondary storage devices. And this can be done with the help of what memory management unit, that is what the hardware. What system or what system uses or sees are essentially a logical addresses, not the actual physical addresses where the pages are stored. These logical addresses may be translated dynamically at the loading time, executions, or compile time, depending upon the requirement or the definition of the system, which kind of system we are using, whether it is NFT based or total phasing is there. So it depends. In actual scenario, processes and resources are stored in the memory are not in continuous. They are broken down into the number of pages and scattered and stored at various random places in the physical memory. With the help of dynamic runtime address translation and paging or segmentation table, we can easily access those pages later as and when required. So benefits of virtual memory is what large programs can be accommodated easily as virtual space available. It is as same as the secondary storage with the system. Less input output required, since leads to faster and easy swapping of processes can be made. More physical memory available as per program stored on the virtual memory. These are the references which I used to create such PPTs.